Hello everyone. I would like to introduce my recent research. I study photon dynamics, and of course I use complex mechanics, but this time we extend it to four-dimension complex spacetime to discuss the uh, quantum particle in relativistic effect, for example, the photon. And the first part of my research will focus on the trajectory. Of course, I like other trajectory interpretation. The wave particle duality is the main part of this topic. I can see some discussions of these in wave particle duality in terms of photon, but I couldn't see a conclusions so far. Maybe I didn't read all the reference in detail. And so in my first part of the research, I will focus on this part, and I try to give a good simulation result to show that the wave particle duality can be demonstrated by the trajectory photon trajectory. And the second part of this research will focus on the spin. As far as we know, that photon is a Bohmian and is a boson. Sorry, I confused about that a little bit between the Bohmian particle and boson. And we know that photon is boson and with a spin 1. The very recent paper we submit is about the electron spin, which is a fermion. So we will continue the spin dynamics in photon, especially in the main framework of the four-dimensional complex spacetime. And we can see a lot of different phenomena here, and I will discuss it in the paper. And the section 3 will be that's very interesting part, because it is photon, so we will have antiphoton. And on the other hand is a kind of pair conditions, for example, the particle and antiparticle. So we have photon and antiphoton. Basically, they can be distinguished by they moving along with the time arrow is moving forward to the time direction or the reverse direction. That will be very fantastic. And in the final part, I hope I can have enough time to finish this, but I only have a month, so I probably cannot reach this part, but I hope I can finish that part. In very recent paper, there is a team published this article. We know that Bohmian mechanics only can be applied to the non-relativistic quantum mechanics, but they use weak measurement to provide coordinate extensions information, especially focus on the relativistic part to apply to the Bohmian mechanics, so they can discuss so-called relativistic Bohmian mechanics. Because in usual, in the past time, some researchers they focus on this combined Dirac equation and Bohmian mechanics to discuss electron in very high speed condition, but they didn't give a very complete framework to discuss this electrons moving and not mentioned about the spin. So we hope we can have these spin embodied into our uh, four dimension complex space time uh, to discuss this. Yeah, that's so far I want. It's my research project. I hope I can finish it in a month, and the time is really short. Yes, I know that, and I think I don't know how many I can finish this. So let's see.